All right, guys. So welcome back, Mr. Moscato with you. I know you were all enthralled with the first video on parallel lines as we continue our snow day adventures here. So this video, what we're going to do is we're going to talk about perpendicular lines. All right. So what makes perpendicular lines? How can we tell if two lines are perpendicular to each other? All right. So let me get back to my iPad and we'll get started with that concept. All right, guys, so we're talking about perpendicular lines. All right, so the first thing that we need to figure out when we're dealing with perpendicular lines is what the heck does perpendicular mean? All right, so perpendicular, all right, means that two lines come together at right angles, that they come together at 90 degrees. All right, so what does that mean, right? So if we take a look at this graph, all right, and I have the line in green and the line in red, all right, they come together at 90 degrees, which means that one of those angles, all right, is 90 degrees. All right, so we take a look at that, all right, and if one of the angles comes together at 90 degrees, then all of the angles are going to come together at 90 degrees. All right, so basically we define perpendicular or perpendicular lines at lines that come together and form a 90-degree angle. All right, so when it comes to perpendicular lines, all right, and determining whether or not lines are perpendicular, all right, we take a look at the slopes. So just like we did with parallel lines, all right, what we need to do is examine the slope of those lines to see if they are perpendicular. The slope of a perpendicular line is the negative reciprocal of the slope of another line. All right, so what does that mean? All right, so when we deal with the word reciprocal, all right, that is a fraction. All right, it's a fractional term. So let's say that I have a fraction of 2/5. Okay, well, the reciprocal of 2/5, all right, as we know, is we flip the fraction upside down and we end up with 5/2. All right, so a reciprocal of a fraction is we take the numerator and the denominator of a fraction and we just flip them over, right? We switch sides. All right, so a reciprocal of a fraction is just the fraction turned upside down. Okay? Now, negative reciprocal means that we are taking that fraction and we are then multiplying it, that new fraction, and we are multiplying it by -1. All right, so that's what we have, right? So we have negative reciprocal, all right, means that we take the slope of a line, all right, and we multiply, we flip the fraction over. In other words, we flip the slope over and we multiply it by -1. Why is that? So? All right. Well, we take a look at the green line. All right, and we can determine whether the slope is positive or negative just looking at the green line. Right. So we look at the green line and we determine that the slope is negative. Right. So how do we do that? Well, the line is going down. If we read the line from left to right and the line goes down, the slope is negative. Right. So we've done that before. Okay. If we take a look at the slope of the red line, all right, and we just look at it, right, and that we can see that the line is going upwards from left to right, well, then we have a positive slope. The difference between a negative number and a positive number is the negative number, right? We're multiplying by -1, right? So to get from a negative value to a positive value, we multiply by -1. All right, so that's why we're using the negative reciprocal of a fraction, and then the reciprocal part of the fraction in terms of perpendicular lines just accounts for the difference between the rise and the run in one direction and the rise and the run in the other direction. All right, so put those two concepts together, negative reciprocal, all right, and now we have a the slope of perpendicular lines. All right, so the slope of one perpendicular line is the um, negative reciprocal of another line, right? So perpendicular lines have slopes that are negative reciprocals to each other. Okay, so that's what we're dealing with. All right, so let's take a look at this problem. Write an equation in slope-intercept form for the line that passes through 4 comma 7 and is perpendicular to the graph of y equals 2/3 x minus 1. All right, so excuse me, they want the new equation to be in slope-intercept form. What is slope-intercept form, you may ask? Oh, we know what slope-intercept form is. Anytime that we have these kinds of problems, right, and they're asking for a form, all right, a specific form of an equation, I like to write the general form of the equation just so I make sure that I am solving for the right thing. Okay, the general form of slope-intercept, all right, is y equals the slope m, all right, times the input x plus the y-intercept b. Okay, so what do we have? All right, write an equation in slope-intercept form for the line that passes through 4 comma 7 and is perpendicular to the graph of y equals 2/3 x minus 1. All right, so we start plugging in the values that we know, and then we solve for whatever else we have to do. Okay, so the equation of my perpendicular line. All right, so we'll just start this way. Y equals, all right, well, if it's a perpendicular line, the slope has to be the negative reciprocal. The original line has a slope of 2/3. The perpendicular line, therefore, must have a negative reciprocal of 3/2, negative 3/2. All right, so y equals negative 3/2 x plus my y-intercept. Now, I don't know what my y-intercept is yet. We're going to figure that out in a moment. Okay, so far so good. All right, we are creating, or we are discovering, the equation of the perpendicular line. All right, so now what do? Well, we have a point at 4 comma 7. That means that when we plug in a value of x of 4 into our equation, we're going to get out a value of 7 from our equation. All right, so remember that this point, right, is in x comma y. All right, so what we're going to do is we're going to plug in the x value and the y value for our point. Okay, so this means that 7, my y value, 7, is going to be equal to negative 3/2 times the input x, which is 4, plus whatever the y-intercept is. All right, so b is the y-intercept. We're going to figure out, we're going to solve for b. All right, so let's do a little bit of math here. 7 equals negative 12 over 2 plus b. All right, so that means that 7 equals negative 6. So negative 12 divided by 2 is negative 6 plus b. We're going to add 6 to each side. All right, so b equals 13. So my y-intercept for this equation is 13, which means that my equation, the equation for this line, is going to be y equals negative 3/2 x plus 13. Okay, so this equation is my solution to the problem. All right, but because, we can never leave anything well enough alone, all right, let's go ahead and graph these two equations, all right, and see if they are indeed perpendicular, right? If the picture matches what we're describing here, all right? So let me draw a quick XY axis here. Okay, so we're going to have something that looks like that, and we're going to have something that looks like that. Hopefully we have enough room. All right. And what we're going to do is we are going to set these x and y values at 2's. Okay, so x and y. So this is going to be 2, this is going to be 4, right? This is going to be 6, etc. This is going to be 2, this is going to be 4, this is going to be 6. So we're just going to change the scale of our graph a little bit, all right, just to make it fit a little bit easier. All right, so let's take a look at this equation first. All right, let's graph that. All right, so this equation has a, let's see, it has a y-intercept of negative 1. So negative 1 is going to be, let's do this one in red. All right, so negative 1 is going to be here. All right, remember that our scale is at is at 2. Each tick mark is 2. All right. And then it's going to have a slope of positive 2/3. So that means that it's going to go up 2 and to the right 3. So it's going to go up to 1, 2, and then over 3. So we're going to have a point right about there. And that's really all I need. All right, so we're going to go ahead and draw our first line. All right, which is going to look something like that. Okay, a little bit off, but not too bad. All right. So this is the graph of the line, right? Y equals 2/3 x, 2/3 x, all right, minus 1. Okay. All right, good. The second line, okay, we're going to do that one in green. Okay. We're going to have a y-intercept of positive 13. All right, so that's going to be, let's see where that point is going to be. That's going to be 8, 10, 12. So this is going to be, right, so this is going to be 14. If that's 14, then this is 12. Then 13 is going to be right here. Okay, and then, all right, the slope is -3/2, so -3/2, which means that we are going to go down 3. All right, 1, 2, 3, and then over 2. Okay, so we're going to have a point there. All right, get my straight edge. All right, and we are going to connect the dots here, and I'm going to draw right through my equation, but that's okay. All right, so there we go. That's the line. That's our perpendicular line. Okay, and this is the line y equals -3/2 x plus 13. Okay, you can see that these angles come together at 90 degrees. Okay, 90-degree angle. All right, so we have a good picture there. All right. So that's it for perpendicular lines. All right, so the things that we have to remember for perpendicular lines is that their lines, their slopes are negative reciprocals to each other. So to get the slope of a perpendicular line, we flip the slope fraction over, we multiply by -1, right? We figure out a point on that line somewhere, wherever it is. All right, and then we're good to go. All right, so that's it for perpendicular lines. I will post some homework for you guys to complete over the weekend. I hope you guys have an enjoyable rest of the day here on your snow day. All right, and I hope you guys have a great weekend. This is Mr. Mascaro signing off. Have a great day. Bye bye.